Hello, I'm Liao. Welcome back to Evan of Code, where we are solving puzzles every day. And today we are on day 8. And so, what puzzle awaits us on day 8? Let's take a look. Day 8, Haunted Wasteland. You are still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she had just finished warning you about a ghost a few minutes ago. Ooh, spooky. One of the camel's pouches is labeled as maps. Sure enough, it's full of documents, which is your puzzle input, about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contained a list of left-right instructions, and the rest of the document seems to be describing some kind of network of label nodes. It seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the camel to follow the instructions, you can escape the haunted wasteland. After examining the maps for a bit, two nodes stick out, AAA and ZZZ. You feel like AAA is where you are now, and you have to follow the left-right instructions until you reach ZZZ. This format is defined in each node of the network individually. For example, so this is the instructions, and this is, I guess, the network. Starting with AAA, you need to look up the next element based on the next left-right instructions in your input. In this example, starting with AAA and go right by choosing the right element, which is C, right? Which means you're here. And then L means to choose the left element of C, which is this one, Z. So by following the left-right instructions, you reach ZZZ in 2 steps. Of course, you might not find ZZZ right away. You might run out of left-right instructions. Repeat the whole sequence of instructions if necessary. So right, left, like this, which really means right, left, right, left, right, left, right, left, and so on. For example, here is a situation where it takes 6 steps to reach ZZZ. So this is left, left, right, left, left, right. So starting with A, you go with left, which is B, and then left, we go back to A, and then right, which go back to B. And then we go left, left, right again. Left, which is going to A, and B going left again, going to B, and then right, which goes to Z, and you are at Z. So starting with A, following left, right instructions, how many steps are required to reach ZZZ? So we're gonna write our code. First of all, we are going to copy our instructions. This is a huge map. I don't even know where is the AAA, but let's copy this. And let's go to our code. We are at day 8, puzzle 1. So as you can see, we have puzzles, solutions for every day, every puzzle, part 1 and part 2. And all this code will be pushed to GitHub. If you're interested to see the solutions, the source code, you can find that in the description below, right? So first thing is we paste in our instructions. And then the next thing is we need to parse our instructions. First thing is the first line is the left-right instructions. So I am going to, firstly, as always, we're gonna split the inputs by a new line, lines, and the first line is the instructions. So I will say instruction equals to input 0, and from third line onwards, we are going to see our map, right? So I'm gonna parse this thing out. And then we're going to record, we're going to use a map to record for each node what is the left and right node. Right, so the map here, the key will be the current node, and then it will be containing an object of left and right, which tells us where to find the next left node and where to find the right node. So we are going to loop through the lines. We start with the third line. And for each line, this is this is an example, right? We're gonna use regular expressions to parse this out. So we're gonna have a match. The first capturing group will be, or let's write our regular expressions first, right? So the we have the line I dot match a regular expression. We will start with a capturing group of 3 letters A to Z, and then we have a space equals, and then we have brackets. Over here we also have the same thing, capturing group with a space, and then here, right? This should gives us 3 capturing groups. So the first capturing group is the current node, and the second is the left, and then the third one is the right. So with this, we are going to populate our map. So map current is equals to left and right. So after we get our map, we know all where from every node where to go to the left, where to go to the right. Then we will start from where our current node is, which is the AAA, right? Let's current equals to AAA. And we're going to count number of steps to reach required to reach ZZZ. So this step right now is 0. And we are going to follow the instruction one by one, right? So we will have besides the step, we are also recording the instruction index, which also start with 0. Okay, so now with the current AAA, we are going to follow while current is not ZZZ. Then we're gonna keep traversing until we find ZZZ, and if we already enter ZZZ, then we will break out the loop, and then from here we can print out the number of steps that we've taken to reach there. So first thing is that we are going to, if it's not ZZZ, then we are going to follow the instruction to go to the next node, right? So for that, we're gonna find out what is the, where do we go, right? So first thing, to get left or right, we can use this one, instruction index. If this is equals to left or right, I think let's don't do this for now first. If this is equals to left, L, then we are going to the left node. Else we're going to the right node, right? I think we can just, instead we put here like this, then it will make it easier for us to index and find the left or right, right? So basically it's this value tells us whether it's left or right. So like this will lead us to the next node. So this is the next one, right? And so basically we're going to go to the next one. It's this one, and the instruction index. We also increment our number of steps that we are going to take, and then we also increment our instruction index. But for this one, we are going to +1, and if we are at the end of the if we hit the end, we want to wrap it back, so I'm gonna +1 and then do the modulus of the instruction length. Like this. Right, so we'll keep going this loop, basically finding what is the current node. Find out from here, based on the map, we know we go to the, and based on the instruction, we go to the left or the right, and then that will be our next node. And then we will count, because we take a turn, we will increment our step and our instruction index. And then if this current is not ZZZ, we'll just keep looping until we reach ZZ, and then we'll break out the loop, and here we get. And then at the end of the loop, we'll print out how many steps that we take to reach ZZZ. Right, so let's run this code. Day 8, puzzle 1. Okay, seems like it's not working. Seems like it's in an infinite loop. Let's break this for a bit first, and let's debug this based on example input. Right? Comment this out. So an example input will be like this one. And then if we're gonna run, it doesn't end, which means something is wrong with the code. Let's see where gone wrong. Okay, so here I'm gonna print out current and see what is the current in the loop. Somehow we stuck in G. We keep stuck in G. Why is that? Why we go to G? So A. Maybe something is wrong with this index. Let's see. Keep going to 0. They have something wrong over here. Instruction index. Let's I think the loop is looping too much and it cut off the input. I can't even know where the start goes wrong. So I am going to come here and say if step is greater than 5, I'm gonna break out this loop first. And in the meantime, I'm still gonna print out the instruction index and the current and see what we get. So we start with 0 and go to A, and then we go to 0 again. Something is wrong. Why we are keep in 0? So I guess maybe the instructional length, or maybe this code over here is incorrect. Right? Let's see. Length is equals to instruction length. Oops. Try and run this again. Length is 1. Okay, something is wrong with this one. Okay, this is lines 0, not these input 0. Right, okay, so now we end at right. Now we are correct. Now the length is 2, and then we ended up at the right place. So here let's clean this. And let's revert back our inputs to the puzzle input. And we get 18,113. I'll put it in. And is this the right answer? Yay, that's the right answer. So we get 1 gold star. And we are going to head over to part 2. The sandstorm is upon you, and you aren't any closer to escaping the wasteland. You had the camels following instructions, but you have barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound by the laws of space-time? Only one way to find out. After examining the map a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number ending in Z. If you were a ghost, you probably just start at every node that ends in A and follow all the path at the same time until they all simultaneously end at the nodes that end with Z. Here there are two starting nodes, 11A and 22A, because they both end in A. Okay, so as you follow each left-right instructions, use the instructions simultaneously, navigating away from both nodes you are currently on. Repeat this process until all the nodes you are currently on end with Z. If only some of the nodes you end on Z, then they act like any other nodes, you can continue as normal. In this example, you'll proceed as follows. Okay, so you first start at this one. You choose all the left paths leading you to 11B and 22B. You choose all of the right paths leading you to 11Z and 22C. And choose all the left paths. So I'm at 11Z, so I'm going to 11B and 22Z. In this case, we are still not all ending with Z, so we're going to choose again on the right paths, which leads us to 11Z again, and in this case for 22Z, we're going to 22B. And now, left path again gives us 11B for 11Z, and then this one will gives us the 22C. 22C is on the left. And then right paths again, in this time round, both ended up in 11Z and 22Z. So in this example, you end up entirely on nodes that end in Z after 6 steps. Simultaneously start on every node that ends with A, and how many steps does it take before you are only on nodes that end with Z? Okay, so we're gonna keep our code. We're gonna duplicate this file. We have puzzle 2, and let's save this. So the logic here is the same. This part we don't have to change anything at all. Just the current node that we are in is no longer just AAA, but we will have a list of nodes that we're currently on, and we're gonna do the same thing where every node is gonna step one step ahead, and once every node ends with Z, then we're gonna break out the loop, right? So first is we're gonna find out which nodes that ends with A, right? So I can have I'm gonna call it the current. I'm gonna use the same variable name, but we are going to find out which nodes that ends with A. So I'm gonna use the object. We're gonna find out all the nodes first. So which is objects map keys. I'm gonna get all the keys. Should be all this the node name, and then we're gonna filter out only those that ends with A. So the node where the node ends with A. Right, so this is the list of nodes that ends with A, and we are going to have the same logic as well. But here, while it's not Z, but this is not what we're testing now anymore. We'll check if while every or while I think it's every while every node that ends with Z, well, it's not this case, then we're gonna continue the loop. We'll stop the loop when every node ends with Z. Okay, so how do we move forward from here? Well, the next node that we have is actually based. We're gonna, for each of the current node, we're gonna basically use the same idea. We're gonna map. For the node, we're gonna find out the next instruction. I'm gonna use the map over here, the array.map over here, because we're gonna, based on every elements in this current array, we're gonna map it to the next element, and then we get this next array where every element in the current will find out what's the next location for each of the elements, and this will give us a new array. I'm gonna assign it back to the current so that later on we can check it again. And same instructions, stepping forward. and also updating our instructions index. And I think that we are kind of done over here. So it's time to check whether our logic works for our goals to travel from anything that ends with A to all nodes end with Z. How many steps does that take? Right, so let's run this. It takes way longer. Probably something's wrong again. Yeah, so let me break this and check whether our logic works again or maybe something is wrong. So let's take up this example again, simple inputs, and let's see whether it works with a much simpler input. So we're going to run this code and hold on, okay, because we have some numbers over here. So this, let's do this one. Let's update our regular expressions. Let's run this and take 6 steps to complete, and that's the right answer. Okay, so the logic wise, there's nothing wrong with our logic, but it's just done slow. Okay, so I guess we will have to think about how we can solve this, or how we can make it faster. Right, so I think the first thing is that one thing that I can think of, okay, let me go back again. One thing I can think of that we can make it slightly faster is maybe, I'm just guessing, maybe we don't maybe we're not creating a new array every turn. Then maybe will that be slightly faster? I'm not even sure. So let's just try and see. Right, so for example, let I equals 0, I less than current length. I doubt this will help much, but let's see. So instead of creating a new node by doing a map, we are going to we're gonna update the array in place so that we don't create new array, and hopefully it takes less memory to do so. And hopefully that would make it faster. Let's try and see. There goes nothing. Okay, it is still not working. Okay, so next thing I think I'm gonna try is that let's see what is in our current, right? How many elements there is that ends with A. Seems like 1, 2, 3, 4, 5, 6. 6 elements that ends with A. And I guess instead of looping through everyone, let's just focus one by one and see how much does each of them take to reach Z. Right, so let's okay, I'm gonna say gonna have a steps that record all this for each element, how many steps does it take, and then for cons let I equals 0, I less than current length I plus plus over here, and then for each of them we are going to do the same thing. We are going to get initialize step index, and then let node equals to current I, and we're gonna for and then we just do node by node, right? Element by element. Node And then this is basically node equals to map node. Then move on. And then at the end of it, steps equals to step. And let's see how many steps does each of them take. Steps. I think doing this is much faster, right? We immediately get some answers over here. So the reason that why it takes much longer to figure out for each of the node, if we iterating through them and figure out where it gets, is because I guess the lowest common multiple of all these numbers is way too big, right? That's why it takes a while to basically reach that number, right? So now we have this basically for each of this to reach any node that has z. This is how many times it takes. I think once it hits z, does it take the same amount of time again to hit z again? Let me think. Once it hits z, the next amount of time to hit another z may not be the same amount of time to same amount of steps to hit the first z, right? So, but I guess there will be some sort of cycle over here where it fits the first z, and then from one z to another z, it's sort of like a loop, and then we will be stuck in one loop, and then maybe we can see how do we get the how do we let's see. I think just with one example, let's let me try and make some change and see. Just test out my idea. So let me see the number of z. I'm gonna go for hitting z the five times before you can call it off. So this one, it will hit z and then it will break, and then because we are still in the loop, we will go again and again, and I guess I'm gonna just print out the step each time. Does it take? And so for the hold on. Let's add some break over here. When it hit Z, it does not go in the loop again. Sorry, hold on. Well, I think I should change it like this. Okay, so here I'm gonna print out I'm gonna modify the loop a bit, and then we're gonna print out every time when it hits the end as z. But then we're gonna do it for 5 times before we can, before we go to the next number. So then we're gonna see is there any patterns on reaching the next z. So it seems like we are stuck in a loop over here every time after once we hit a z, right? So from here, seems like there's a pattern where I'll go back to the same thing again, and then plus another 13201 to hit this again, and then we hit this again. Hold on, no. This 13201 plus doubles is this one. It's okay. And then plus 2. This is plus 3 is here. And then plus 2 again, it will hit. Yeah, it seems like it's in a multiple of the same thing, right? This goes the same as well, right? If we just skip times 1, times 2, times 2, times 3, and times 4, times 5, right? Same thing goes with this one, and same thing goes with this one as well. So it seems like once you hit Z, based on the input that they design, seems like it will stuck back at the same thing again, right? It will take the same amount of steps to go back to reach the next to go back to reach the z, another element with z again. So it seems like we are just gonna find the lowest common multiple, like how many times that I need to increment this one, how many loops does it take, that it will reach the same. Maybe this will take maybe 5 loops, this will take 4 loops until they reach the same number, and that is basically the multiple. This number of steps are the multiple of this one, and these are the multiple of this number. I'm gonna find the lowest common multiple for these two numbers, and we reach one number, and then we're gonna have that number as to see whether what is the lowest common multiple for that and with the other numbers until we reach the lowest common multiple for all the numbers, and I guess that will be our answer. Okay, so here we come back to our code. Let's revert some of the changes that we just made. Right, so basically we get all the steps now, and we're gonna find the lowest common multiple for each number. Right, so I think I'm a bit foggy on how to write the lowest common multiple, but let's just define this number for this function first. Maybe we have a and b, two numbers, right? So our answer will be basically we start with 1, and then we get the for every step, for every node that starts with A, the number of steps that they take to reach Z. For each of this step, we're gonna say answer is equals to lowest common multiple of the answer and the step amount, right? And then lastly, we're gonna print out answer, which should be our answer. So next is we need to figure out how to get the lowest common multiple, right? Lowest common multiple. I don't really remember how to figure that out, so I'm gonna Google a bit. Lowest common multiple, JavaScript. And okay, we have some functions over here. So I guess this is the code. So it starts with num1 and num2. And and I guess when you reach here, the lowest common multiple is the mean. So here we're gonna return mean. I think this is more of a naive solution. Let's find a more I wonder how long does it take. It looks a bit naive where you just get min plus plus and keep going on. Let's see. No, that's too slow. Let's see. This is awkward. Let's. Lowest common multiple is a times b divides by the greatest common divisor of a of b, and then greatest common divisor is this thing. Okay, let's see. So I'm gonna come back over here. So lowest common multiple is this one. And this is based on GCD, which is this. And let's change back our parameter. And let's try and run this code and see whether it works. Gives me a number, so it looks promising. Let's try and see whether we can run. Is this the correct answer? Let's hit submit. And that's the right answer. Okay, yay! We get 2 gold stars with a little bit of cheat getting the lowest common multiple. So implementation online, but nonetheless, I think the way of solving it's there. We managed to solve this puzzle with our code, and we get 2 gold stars. And I think that's it. So we have finished 8 puzzles, which gives us 16 stars, and we shall go on to the next day 9 puzzle, and I will see you in that next video. So see ya, bye bye.